Hi folks, in this demo I'll show you how to replicate a bunch of tables in a source Postgres database to a target Postgres database using initial load and change data capture. The highlight of this video is how PeerDB parallelizes the initial load of a large table to significantly improve load times. This feature is unique to PeerDB. So first, let's go ahead and connect to PeerDB using PSQL and create our peers. I have a source peer, which is an RDS Postgres database, right? This can be Postgres anywhere. It can be on Azure, it can be on premise, it can be anywhere. Next, let's go ahead and create the target peer. And if you see, this is another RDS Postgres instance. And the target peer can be a Postgres database or Snowflake or BigQuery or Kafka or S3, right? For the replication. Next, I have a bunch of tables that I want to replicate: the accounts, branches, and tellers table. And the accounts table is the largest of them all. It has around 100 million rows in the source peer, if you see, right? Next, let's kick off the create mirror command that PeerDB provides for replicating data in the source peer to the target peer. I'm doing it for all the three tables: accounts, branches, and tellers, right? And I'm specifying that as a part of the replication, copy existing data in these tables, number one. Then under the covers, use copy command with binary format to read and write data from these tables, right? Number three, use 8 threads per table for the initial snapshot, right? And this is the unique feature that PeerDB provides, that you can even parallelize the initial snapshot at a table level, right? And then I'm specifying I want to do snapshot for 2 tables at a time and load 1 million rows per table per thread, right? So let's go ahead and kick off this mirror command, right? And the mirror has started. Now let's quickly go ahead and connect to temporal to monitor the mirror, right? Okay, so the mirror has started and the snapshot, the initial snapshot has started. If you observe, the pgbench tellers and pgbench branches have already been copied to the target database. Let's quickly go ahead and check that. Select count star from target underscore peer dot pgbench underscore tellers. You see the 10,000 rows are already loaded. And then let's go ahead and see the branches, right, which is 1,000 rows. The accounts is still going on, and if you see, there won't be any rows. So the way PeerDB initially loads large tables is that it holds a connection active to maintain a snapshot, then logically partitions a large tables based on CTID ranges, which are tuple identifiers in Postgres, and then streams multiple such partitions in parallel. Here I specified the number of threads to be 8, right? So 8 such partitions are streamed in parallel to the target database. The target can be Postgres, Snowflake, BigQuery, right? And because of this parallelization, load times of larger tables drastically reduces, right? Terabytes can be moved in few hours than days. Let's look at the status of the mirror. Okay, looks like the initial load is finished. If you see, the snapshot flow is completed and the change data capture, which is here, the sync flow has started. So let's go ahead and quickly check data in the target peer in the accounts table, right? It has 100 million rows, right? So let's see how long the initial snapshot took for syncing these 100 million rows. And if you see, it is less than 5 minutes, right? So it's 4 minutes 30 seconds, right? So this is the power of parallel snapshotting, right? Like by parallelly loading a single large table, initial snapshot times can drastically reduce. And now if you see, the change data capture is going on. So as I add rows to the accounts, branches, and the tellers table, they will be reflected in the target peer.